Okay, in this lesson we're going to look at using the Cartesian formula for the area of a triangle to actually find the area of a quadrilateral. One thing to note about quadrilaterals before I start, that every quadrilateral can be broken up, and take any quadrilateral. By drawing a diagonal, I can break that up into two triangles. So if I can find the area of the first triangle and the area of the second triangle, well then I'm in business. Okay, I can find the area of the two triangles together. Okay, so it says find the area of the quadrilateral. It gives me 4 vertices. One thing I want to make sure that I do is, I divide this triangle, this quadrilateral, along its diagonal. So before I do anything, I'm going to draw a rough sketch. And I mean a rough sketch. I don't need to draw this out with any huge degree of accuracy. I'm just going to get a kind of a good idea of what's going on. I've got 0, 0, which is great. 4, -1, that's right 4, down 1, so again, this is not accurate. 2, 3, right 2, up 3, maybe somewhere around there. -2, 4, left 2, up 4. So what I have is this kind of quadrilateral. Here's my quadrilateral. And what I want to make sure is that when I'm dividing it into two triangles, I choose the right kind of diagonal here. So I'm going to divide it into two triangles along this way. Remember, there's the point 0, 0. There's the point 2, 3. So the other 2 points are this one over here, 4, -1, and -2, 4. So what I'm going to do is I'm going to first find the area of this triangle over here. Let's call it area 1. And then I'm going to find this triangle, area 2. And then I'm going to combine those two areas to find the area of the full quadrilateral. So let's look at area 1 first of all. Again, the area of any quadrilateral is equal to, and let me write down the formula first maybe. The area of any triangle can always be written as half times the absolute value of x1, y2, subtract x2, y1. So the first area can be written as a half times the absolute value. Make sure 0, 0 is part of the triangle. It is, so I'm going to use the other two vertices as x1, y1, my first point and my second point. So my first x coordinate times my second y coordinate, that's going to be 2 times 4. Minus, and then I'm going to look at my second x coordinate minus my first y coordinate, that's -2 times 3. Watch out for the negative here, so minus, I'm going to make sure to put that in brackets, -2 times 3. Okay, you can actually type that straight into your calculator, including the absolute value brackets. That'll go in, ABS, absolute value brackets, on your calculator. But I'm going to just work it by hand here. That's going to be half times. We're going to have 8 here. That's going to be -2 times 3 is -6, but we're subtracting -6, which is the equivalent of adding 6. So I'm going to get a half of the absolute value of 14. You can see, hopefully, that that's just going to be 7. So my first area there is going to be 7 units. Okay, so that's part of my solution. I'm just going to keep an eye on that. And now I'm going to look at the second area. Again, I'm using the same formula. A2 is going to be a half times the absolute value of, the first x coordinate times the first x coordinate times the second y coordinate. So it's going to be 4 times 3. Subtract the second x coordinate, 2 times the first y coordinate, -1. So 2 times -1, and that's what I'm looking at. Again, you could plug that straight into your calculator, including the absolute value brackets. I'll work it by hand. 4 3s are 12. -2 times -1, well, that's +2. So again, I'm getting half of 14, which is 7. And again, units squared. That's my second area. So I have my two triangles. The area of triangle 1 is 7, area of triangle 2 is also 7. So they have the same area. Therefore, the area of the quadrilateral is going to equal to, well, we know it's equal to A1 plus A2. So we know that. I'll get rid of those. We know that the area of the quadrilateral is A1 plus A2, so therefore the area of the quadrilateral is 7 plus 7, which is 14. And what are the units? We don't really know here, so I'm just going to write units squared. Okay, so that's the area of the quadrilateral. It's 14 units squared. That's my final answer. Okay, so we can use that area of a triangle formula actually to find the area of a quadrilateral. We just divide the quadrilateral up. Do draw a rough sketch. Do get an idea. You want to make sure to divide that along the right diagonal. Okay? So there'd be no point in dividing that quadrilateral along here because one of those two triangles would not have 0, 0 as a vertex. Alright? So make sure you're choosing the correct diagonal. Alright? Practice, practice, practice.